Hey guys, welcome back to another video. So today we are going to be continuing our stick welding series, and we're going to be working with 7018 today. Probably one of, if not the most common welding rod that you'll run into. So let's grab all your chipping hammers, your brushes, and your safety equipment, and let's get right on into it. Alright, welcome back to the machine noise. So if you guys remember from my last video, I'm running an Everlast welder here. It is a DC welder, and let's go over the settings for 7018. Now, I've kind of already preset this a little bit. You can see from the last video I got my synergics already turned on. Here's what the settings I have. So you can see I've got a 7018 rod at an 1/8 inch size. That's the rod that we're going to be running first. Now, the material I set it at 1/4. Technically what I'm welding is a little thicker, but I like this setting a lot. And the amps I didn't even end up messing with at 125. Most of the time when you go to school and whatnot, they're going to tell you to start running these at 120 amps. In my experience, a little bit hotter or a little bit more amperage usually helps out when you're getting going. So that would be my recommendation. So 125 amps. Let's go over and talk technique and all the other little fun stuff, and then we'll get down to welding a bead. Alright, so I went ahead and shut off the welder. If you guys were here from my last welding video, you'll recognize this piece of metal, and this bead up here was the 6011 that we ran last time. Now, while I was getting ready for this video, I did a quick practice run over here. This bead right here, this one right along here, that's a 7018 bead, and unfortunately it's kind of hard to see with this camera, but I wanted to discuss something with you real quick. So last video I tried to touch on what a crater was. Now this one kind of shows it a little bit better, but not entirely all that great. So a crater, right here's the end of my weld bead, and if I can get this to focus a little bit, you'll kind of see that there's a bit of an indent right at the end. So I managed to stop myself before I filled this in so that I could show you guys. So what happens is, as you snap that arc off, because that's what you got to do, you got to snap that arc to get it to shut off. You don't want to gradually drag it away, otherwise that arc goes on and then you dump a whole bunch of voltage into your weld. You want to snap that arc off. In the act of doing that, you usually don't get any deposit right at the end. Now there's a couple of things that you can do to kind of minimize the effects of cratering. So as you're going along, we'll just pretend this is my arc rod, you're going in there at your good drag angle, yada yada yada, going along. When you get to the end, there's a few things you can do. Usually what I'll do is I'll actually backtrack just a little bit. So I'll get to the end and then I'll pull back just a little bit, pause for just a second, let it fill in, and then snap my arc off. That usually helps a lot, and most of the time I'll even come back in and just restrike right on the end, let it fill in a little bit more, and then snap off. Biggest thing, and the reason that you want to do that, is because these craters here, especially if they're really deep, if they're a really deep indent, they will cause a crack. This is the #1 place where welds fail, is in this crater if you don't fill it in and it cracks. So that's kind of my little rant on craters. Make sure you come back and fill those in. Fill them in for it. Now if you remember from our last video with 6011, the thing that you did with 6011 is you came in, you tapped it, pulled and back, and then you got your arc going. You don't normally do that with 7018. Usually 7018 is what's called a strike start. So you're going to come in and you're going to pretend that you're striking a match. So you're going to come in, glance off the metal, come up and get the arc started, and then come back in. So it's like striking a match. You just bloop, just like that. And that's how you strike an arc for a 7018. Now, once you get your arc started and it comes in and stabilizes, the next thing that you're going to do is you're just going to hold it to the plate and drag it along. It's going to feel like you're dragging that rod along. And that's how you run a 7018. For the most part, you should have enough flux on the end of your rod that as you drag it along, that flux will be maintaining your arc length. So, come in, strike it, pull back a little bit, let the arc stabilize, and then just drag it along that plate. Alrighty, so there's our pass that we just ran. You'll notice that I got a little bit cold on the end start there, but all in all, I'm pretty happy with that. Ran in fairly smooth. I got a little inconsistent right here in the middle where I didn't quite have myself stable enough, but that's okay. That came out as a fairly decent pass. The toes are all very well tied in, and that's basically the main thing that I'm looking for when I'm running welds, is to make sure of that. Now, grab my pliers here. This over here is a chunk of 7018 slack. It's a little bit different from your 6010, and my rule of thumb is if you can get the slag to kind of peel off in these relatively big chunks, then you've done pretty good. That's usually a good bead. If that slag can peel off, you usually have your settings pretty close to where you want them. Now for that bead, I might have gone up another couple of amps. It did feel just a touch, just a touch cold, just a little bit. But all in all, I was pretty happy with that bead. Now you probably noticed that during that last shot, you probably heard me chip away. My apologies to the headphone users. Hopefully the chipping didn't get you too badly. And then I came back and restarted. Even though I whipped back just a little bit for that crater, I still came back and restarted because I felt more comfortable doing it that way. So, all in all, that ended up being a good bead. I'm sorry that the camera doesn't quite pick it up as good as the human eye can, but unfortunately we do what we can. So, one other thing that I was thinking about here that I kind of forget to mention. So, hopefully you can kind of see this, but this is the end of my welding rod. This is the end of my 7018 after I weld it. You'll notice on the end here, hopefully, the actual metal part of the rod is fairly well recessed back into the flux. This is called a crucible. Now, depending on what quality of rod you had, these crucibles can be a royal pain in the neck. So, now that the metal part of the rod is recessed back in, if you go to restrike it, it won't strike. So generally, you're going to make your run with your rod, and then you're going to break it off. Now with 7018, unlike the 6011, the chances of you getting it to restart really quick are pretty slim because of that crucible. There you go, there's a good shot of it. So, stop what you're doing, chip your weld, and then come back in and just break that crucible off with your thumb. You know, you just come in and squish that crucible and just break it off. This one doesn't want to break. I'll probably have to smash it a little bit with a chipping hammer. That'll happen sometimes too. Sometimes these don't like to break off. Nope, there it goes. And now I've got rod showing again, and I'll be able to restart my arc. So keep that in mind when you're doing 7018. That crucible happens on pretty much every rod. Now sometimes, again, this is kind of a depending on the quality of your flux, you'll get a cap of solidified flux on there that won't break off with the crucible. If you get that cap, grab your handy dandy chipping hammer and just come to the tip and just tap it out lightly. You don't have to go very hard, just enough to break the flux off, and make sure that you have bare metal for when you go to restart that arc. So there's that. I'm going to go ahead and go over the setup for a 5/32 rod, and we'll go ahead and run one of those and just kind of discuss some of the differences. Alrighty, here we go. So now I've got a 5/32 rod in the electrode holder, so I went ahead and adjusted my machine. Unfortunately, I only got the 2 settings for the material thickness, which kind of bugs me, but you'll notice that we went from 125 up to 140. Now, initially, my machine had it set at 145, but because my material, that plate of steel, is already a little bit hot from welding on it with the 1/8 inch rod, I went ahead and just kind of toned that back a little bit, and we should be doing pretty good. And that's going to be something to remember when you're welding. It doesn't matter if you're using the same rod or you're switching rods, whatever. As your material gets hotter, you can ease back the amperage a bit. So always keep that in mind. Anyway, let me go ahead and set up, and we'll go ahead and run a 5/32 welding rod bead. Alrighty, so as you can see, a little bit of a different slag. I wanted to just kind of take a moment and kind of show you that. You'll notice that it didn't really want to start too well for me, and you know, the long and short of it is that the bigger that rod gets, the more difficult it can be to get it to start and to stabilize, and that's just kind of the nature of the beast there. So whatever rod you end up choosing, make sure you spend some time practicing with it. It's been a long time since I've run a 5/32 rod, so that was kind of part of the issue with me, is it's just been a long time since I've run it. But let me go ahead and chip this, and I'll just go ahead and cut it and save the headphone users' ears, and we'll be right back. And there's the bead right there on the top. So it actually ended up laying in pretty decent, except for this one spot where I got a hole right there, and I kind of welded into that a little more than I wanted to. But all in all, it came in pretty good. Now, it's kind of hard to see on the camera. I'm going to try and zoom in here just a little bit, and hopefully we can get some sort of focus. Now, if you look along the top toe of that weld, grab a little pointer here, right along up here, you'll notice that it's pretty flat. It's not really built up. Now, this is the beginnings of undercut, which is probably happening because of how warm I have my material. I managed to save it, but it's kind of flowing downwards. It's kind of building up just a little bit under there and kind of getting a little bit globby along the bottom. Now, a couple of points for that. A, my material's already pretty warm, so it's going to be a little bit harder for the weld metal to stick consistently along the hot material. It's going to want to be very liquid, and gravity is going to start drawing it down. So that's part of it. B, I swapped to a bigger rod. Bigger rod means more metal. More metal means more heat. More heat means a little bit more liquid, and it's going to want to keep drooping down. So if you're going to go with a bigger rod, definitely try and get on a colder piece of metal, or even a thicker piece. I mean, these are relatively thick, but that 5/32 rod takes a lot of heat. So tune your rods according to your material is best advice I can give. 3, another reason that that's happening is you'll hopefully kind of notice underneath it, I've got about 2 or 3 other beads stacked under this. So I just keep stacking beads and keep stacking beads, and eventually all that kind of piles up, and it gets a little bit harder to make a really consistent weld. Don't get me wrong, I'm very happy with what I ended up getting. It's a fairly good weld, but definitely some things to keep thinking about. And that's another thing, is while you're practicing, shove as much metal onto a piece of scrap as you can. You know, I've got beads stacked up all over this, just trying to make sure that I have everything set and that I know what I'm doing before I film, usually. So, but anyway, that bead ended up coming out pretty good, all in all. I'm going to go ahead and end the video here, and hopefully you guys learned something. Hopefully you guys feel a little more confident in teaching yourselves to weld, or just found something that helped you become a better welder. So until next time, this is Welding Eldon signing off. Peace.